Hi, Carl.
Hello.
So let's see. Um, so always like to start. If you could just tell me a little bit about yourself, the project you're working on. Um, yeah, just a little bit about that.
Let's see. Hey, I'm Carl. Uh, I've been working with Rust for no, not as long as you. It's
Okay.
been I don't like 5 years now. I don't actually know when was 1.0 released. I think it was like I
2015.
started like I think I started like a year or so before that.
This date is seared in my
Um,
memory.
yeah. Okay, so it's actually was just about 5 years. And well, what I always say is I got into Rust because I wanted to write a database, and there was no I/O, no networking or anything, kind of that infrastructure minus like your basic sockets blocking read and write. So I started Yakshave, and I'm still in that Yakshave,
I feel like that's
trying
a
to
common story.
yeah
I wanted to do X.
yeah
I started building primitive very first step towards X.
yeah, and I haven't bumped up to the next layer, the actual database part, but probably never will. But I'll still put my yeah. So I mean, I started working on Mio, which is the goal is just to be as light as possible, portable layer for um, non-blocking I/O with Rust, and at a high level, it really focuses on being as light as possible on Linux and um, generally on Unix-like platforms, and then does the best it can. Given that as the goal, it does the best it can with Windows, which means it tends to be better than like tends to be better on Linux than other IO abstraction layers because it is the ePOL interface, so it's zero cost on that front. And it tends to be not as good on Windows. And this is recorded, but I don't think that tends to be a very high priority to get. I think it's better to be more efficient on Linux than it is on Windows for not blocking IO these days. And I've had a few conversations with the Windows networking core service people, and I think they have on their roadmap to improve the portability story from Unix to Windows. So there may be a better story for Windows coming
Hmm.
one day.
That's interesting. Like when you
Um,
say not as good, I mean, is it a? I'm assuming it's a relatively small kind of overhead, but is that
I mean,
incorrect?
it's honestly, I don't even benchmark on Windows. I just hear it's not that. I mean, it's okay. It's basically fine, right? It's for Windows. I think it's fine. If you're doing really high performance
Yeah,
um,
you might see it then.
networking server stuff, you might see a thing. But it's not terrible. It's just not the same level as like a libuv or something like that.
Okay.
Though there's a change from Mio.7, we're working on a re-implementation of Windows that will be better. It's actually the strategies provided by like Bert Belder of Node.js. So it's kind of like libuv Node.js thing. Knowledge is coming to Rust, I guess, but it's going to use a private Windows API that gets you the ability to simulate ePOL much better. It's private in that you're not supposed to be using it, but it's been stable since I think Windows NT, and it's used. It's generally used in Node these days and many other. It's
Mm.
basically if they broke it, they're going
Yeah,
to
they
break
break a lot of stuff.
large amounts of stuff. So um, yeah,
So
it's going to be better. We're still working through bugs. It's a big change, but once we get through bugs, we'll be able to bench it again. And I think I'm gonna see what it's looking like there.
that kind of we kind of skated right into the next question I was going to ask you. So I'm going to ask it now, which is
Sure.
like, what are the big pieces of sort of what are the big crates and what are the, if you took a look at the Tokio a little bit below the
Yep.
hood, what are all the like major pieces and how they interoperate from your point of view?
All
Mio is
right.
kind of the
So,
bottom layer, right?
yep. Mio is like the very bottom layer. Then right above that, there's Tokyo, which, and I guess like there's like Mio's the very bottom layer. Then there's like kind of to the side, there's futures and async awaits, which is, um, and then on top of that, those two things, there's going to be Tokyo.
Mm-hmm.
So Tokyo kind of brings together like non-blocking IO, async await with Rust, like scheduling concerns, timer concerns, those kinds of things. Basically, the components you would expect to be available when doing asynchronous programming. Then on top of that, there's going to be like, I would put like Tower and Hyper and Tonic and those kinds of libraries um, together. So like Tower is a request response abstraction, very similar in like philosophy as like Rack for Ruby, though that's Rack and Ruby is like HTTP specific. Tower is generic with protocol. Finagle for Scala. Um, there's like most languages have some sort of request response abstraction, and that's kind of like your interface layer between some like Hyper and an application framework like Rocket or Warp, or yeah, then there's like all those HTTP frameworks. But the let's see, so Tonic, just people might not know, Tonic is a gRPC implementation for Rust that is async from the get-go. So async, now I'm going to say async to generally reference async await. Let's see, Hyper is the HTTP client and server implementation. Let's see, Tower still has to be updated, but like I said, it's going to be kind of more of an abstract request response library. The advantage of abstracting request and response is that, well, one, you can decouple the implementation like Hyper from the application like Tonic. So Tonic is implemented directly on Tower. It's just like when you define a gRPC server, it just generates something that implements Tower service, and then you can take that value, that Tower service value, pass it to Hyper and say, please run this. And it's also has the advantage of being kind of symmetric. So a Tower client is a value that implements service, and as a user of the client, you call the service. And a Tower server implementation implements service as well, but it like receives the calls. So the server, like the Hyper server, calls the Tower service. So you can actually take like something that implements Tower service directly and use it as a client. Anyways, it has a nice symmetry, which has nice properties. Kind of hard to get into, like it gets really abstract if we're just talking about it without any diagrams or anything.
You kind of lost me right somewhere in there.
Yeah.
If I understood, Hyper is exporting. Right. It's a service abstraction, and Hyper itself is a kind of service. Is that correct?
Yeah. So what you could, so basically, because the Hyper client implements service and the Hyper server drives a service, if you took a Hyper client, connected it to an endpoint, and then passed that and say, hey, Hyper server, run this, you just implemented a proxy.
I see. Yep.
Okay. So,
I mean, you said still has to be updated. You said Tower still has to be updated. Did you mean to async await?
I don't. It's to the standard future. I don't think so. Right. We'll probably get in this, but we can't nicely implement Tower with async await yet because async await in traits has like limitations. And I think by limitation, I mean it like you can. I mean, there's the like. I'm sure you're aware of the async traits macro that David has.
Yes.
And that's great. And I think Tonic uses it. But it's, I don't know if we want to I don't know if we want to include that directly into the tower service trait
Mm-hmm.
or not, because it forces boxing, and tower service is trying to be somewhat low level.
Yeah.
And if I remember, there's like so tower service is more than just like an asynchronous function. So it's more than just if you had like an async FN trait. There's also the concept of back pressure built in, and like it's still unclear how to make it all work together with async await. There may be a way, but every time we dabble with it, we're like, I don't know yet. So as of now, like I think the initial release is just going to be like, we're just going to update it to require unpin and something like that.
Okay, and it could still use standard future.
Yeah, it's going to use
but not
future.
necessarily async await.
Yeah, I mean, you can use async await with it, but you then have to start boxing.
Yes. Okay.
Right.
Right.
Which is kind of already you have to box for async the async traits macro. So it's kind of half of one, half of like you could probably like you might be able to implement like a tower trait macro that takes an async function and implements the tower. So I don't know. This is like a few months down the road for me.
We can probably come back to this question later, but it's actually interesting to me because one of the things I wonder is if we, for example, stabilized some portion or made progress on some portion of infiltrate, might that be enough specifically for the tower service trait? I think tower service doesn't require GATs, for example, the last time I looked. But
I think it's TBD, but
because I think it would be interesting to know. Like I think the full async FN traits is going to be not on.
Yeah,
it's going to be longer, but there are some milestones along the way that might still be of use.
Yeah, you'd have to. I think it might require some sort of GAT, as you say. I don't know. We'd have to play around with
it. Okay. Yeah.
Because you'd want. I mean, there may. I don't know. I just haven't like considered possibilities yet.
There might be something to dig into another time.
Yeah.
Okay. And on top of this, things you've told me so far, we have like Tokio, we have Tower, Hypertonic, and then I guess lives somewhere like what you said, Warp, or one of these sort of HTTP framework layers.
Warp is kind of like next to Tonic in the stack. So both Tonic and Warp are built on top of Hyper and Tower. And well, I mean, so like they're built on top of Tower, but there's sugar for like using them directly with Hyper as well. Just like it's kind of just like I don't know. It's just a minor sugar. Like you're just saying, I want to listen to this address instead of having to create the tower service value and then start your Hyper server. There's like sugar for combining both in one go. So and Warp is just implementing HTTP service, like whatever HTTP. It's an HTTP web application framework kind of thing. And Tonic is the same thing, but with gRPC. And gRPC, for those who don't know, is actually built on top of HTTP 2.0, so, which Hyper implements. So they're both driven by Hyper.
To what extent are those different layers coupled to one another? Like I think that Fuchsia, for example, uses Hyper, but they don't use Tokio because they have some different abstraction underneath.
Yeah.
But can they use? Could they use Warp, for example, if they wanted to?
You'd have to ask Sean that. I don't see why not, because it's just in theory. I don't think Warp is built on top of tower service yet, but that will be the next step. Like a lot of these stacks are kind of evolving in parallel with like knowledge of what the other parts are doing, with the eventual goal of getting them together. But so Hyper, for example, the next version of Hyper being released any day now is going to be on, like you require the tower service to ship. Like I think Hyper 012 defined its own service trait, which was the same. So I would assume like you'd have to ask Sean to confirm, but I would assume like a warp would then like be built on top of service because it's going to need to be past a hyper, which will take us tower service anyway. So I mean, they're pretty, in general, yeah, in general they're pretty decoupled. Like the entire point of tower is to decouple these stacks,
right?
From a kind of practicality point of view, I think there's probably points in which like things are going to be way easier when they're glued together, right? And most users just want to get something going,
right?
Like Tokyo 0.1 was like each component was highly decoupled, such that you could use like the IO driver separately, the timer separately, etc. And I don't think, from a practical point of view, I don't think anyone really took advantage of that at all, and it added complexity. So Tokyo 0.2 is we like combined to one crates, but we're using feature flags to let you opt in, and there's more or less you can still like run any component of Tokyo standalone, and you can integrate it in whatever. It's just the way you do it is a little more kind of there's definitely like the different components now take advantage of having the others within the same crates, if that makes sense. So like if you took Tokyo and you compile it only with a timer feature flag, nothing else will be enabled, and then when you start the Tokyo runtime, it's going to only be like the timer, if that makes sense. And then if you compile Tokyo with everything, you can still configure a runtime to only enable the timer. But by default, it's going to start all the various components. And I mean, the runtime handle lets you, so like to drive something like Tokyo, you generally need like, well, originally named, like with great originality, named a driver. Just like whatever is running kind of the executor and the Neo handle and the timer handle and all that, you need something to drive that. And there are two ways of doing this. One, you spawn a runtime thread that happens in the background, or you don't spawn a runtime thread and you require it to be run somehow. So the original Tokyo, like 2+ years ago, used a static global, but that's ended up having a number of issues when like people getting this thread started unexpectedly, not being disabled and not being able to configure it, not being able to, like, it caused problems in an embedded environment, etc. So after learning from all those experiences, we ended up making kind of the runtime something a lot more explicit, where it has to be started and you have to say when it starts. When you're just using Tokyo out of the box, there's, again, sugar to just do that for you in common cases, like the attribute macros, the Tokyo main and Tokyo test adder macros is basically just start a runtime and execute this async function within the context of that runtime. But if you don't start that, it's not going to start in the background implicitly. You have to then create your runtime handle and start it where you want it to be. And you can just do, like, in any context you want, you can just be like, enter the context of the Tokyo runtime and do my stuff. Because there's like runtime.enter, closure, do whatever you want.
Yeah. And okay. So let's turn a little bit to the main topic that I wanted to bring up of, like, what do you think is most useful for the Rust organization to do in the next, let's say, in the relatively immediate term, and also looking a little further ahead?
Like, stabilize stream like you did Future.
Stream, okay.
Like it's basically ready to go. It seems like it's basically ready to go, and pulling in. So I think I blogged about this. I want to get Tokyo 1.0 shipped in Q3, no later than Q3 2020. And one of the kind of selling points of Tokio 1.0 is it's going to be an LTS release, long-term support release. So to do that, it has to be structured in a way that it is forwards compatible. So I mean, there's going to be a component like I've been working on this for, well, by then it will be at least 4 years. So I kind of have a sense of what we can stabilize for the next 5 years. But there's also going to be like, it has to be structured forwards compatible way, and part of that is going to be no external dependencies on crates that don't share the same release cadence. So, I mean, because if otherwise, like, I mean, that's not true. So, like, no public dependencies, right? It can have private dependencies. That's not a big deal. So, we can't, like, Tokio 1.0 is not going to have a public dependency on futures core .0.3 stream.
Right.
So
yeah, that makes sense. And when you say LTS, do you have a specific time? Right. Yeah. Do you have a specific time frame in mind? 3 to 5 years?
No breaking release for 3 years, and continued maintenance for at least 5.
Okay.
And that's not saying there is going to be release. Like when we ship it, it's going to basically be like, I can't anticipate a breaking release. I'm not going to say, obviously, we're not going to issue Tokio 2.0 ever, but that might happen. Like it might be that there will never be a 2.0. And if I had to guess, I would guess that 2.0 will be further out than 3 years, if there is one.
And you feel like Stream is the major?
Well, simply put, like, we won't depend on Stream. Like, it's not going to block a 1.0. It just means that either I won't implement future Stream there. I mean, obviously, when I say there are others, like there's the other Tokio team members, but I will push to not include a public dependency on a futures-core 0.3. Like if their futures core exists long term, I would hope that then it would be fully adopted by like Rust as I don't know, like it's in Rust Lang Nursery, which is still unclear. I've noticed that there's some question of what that means.
Yeah, that should just be
and
moved.
I know and I know there's talk about moving Stream into standard, and I know there's talk like for generators, except like and
right.
Whatnot.
So I think the specific concern that I've heard raised over Stream has to do with the fact that when you get back an item, it has to be an owned item, and you can't sort of reuse an internal buffer across iterations.
Is that any different than iterator?
No, it's the same.
Yeah.
And it would be useful in the same. I mean, it would also be useful in iterator from time to time. I personally kind of lean towards, well, we should do it because it's analogous to iterator, and we'll probably introduce some sort of streaming iterator and streaming stream concept at some point when we have generic associated types available, and we'll figure out
stream.
I would prefer a different name. And we'll figure out how to bridge that at that time. But that is the main only concern I've heard raised. I'm curious about other traits like async read and async write. Those are the two major ones. That are that you might also want to publicly depend on if they existed, right?
I think that there's a strategy moving forward, which is like so just because I don't depend on futures core Stream in 1.0 doesn't mean that I'm not going to depend on Stream once it's in standard, right? It just would add some roughness to the library to do so, but that's basically what would probably happen. What would happen is I would probably copy Stream into Tokio and use that with the hopes that the standard version will match exactly, and then I can just re-export it silently. Though I don't know if I can do 2 core. Anyway, I don't know if what I could do there. Either I'd silently export it, or I would.
Sorry, I'm a little confused. You're talking about if we didn't have stream in standard?
In standard by Tokyo 1.0.
Right, okay.
I would have to do some sort of thing, like I would have to include stream in Tokyo, and with the intent of deprecating it eventually. So some deprecation strategy is fine because that's forwards compatible.
Yeah.
It's not ideal, and I hope stream is stabilized in standard in the next few months. But I mean, so stream is less core to like Tokyo's, like basically the stream trait as it exists in Future's core is basically fine as far as I can tell, minus the limitations that you said. But honestly, it's the same as iterator, and down the road you can figure it out. I mean, I feel like GAT is so far in the future. You might even come up with a strategy to evolve standard library with additions and being able to break trade. I don't know.
Right.
Maybe you had trade versions, and I don't know, but I think you should just stabilize it.
Okay.
For async read and async writes, I think there's still design work to be done. As you've seen the OpenPR,
right,
that the work that Sean proposed, there are improvements to be made. I know I still have to circle back. I know Without Boats wrote a comment fairly recently, but like Tokyo.2 was coming out, so I wasn't able to internalize it. But the argument is that async read and async writes, as proposed by Futures.io, matches standard IO read and standard IO writes, which has appeal, but I think the advantages of fixing the traits. So there are problems with the traits. The two main problems right now are that there's no safe way, like really good safe way to pass an uninitialized buffer to read. And that has significantly, by significant, I'm not saying like multiple orders of magnitude, but measurable performance impacts in real world applications. So it is not great to have to zero out buffers when writing an IO, like a pretty high performance IO application.
Yeah, so and specifically, I think
thrown out
for things like proxies or things that are very thin layers at top, that seems like it would be where you'd have the most, obviously, and less so.
Yes. So okay. Well, that is true. But I think Rust's appeal is low level. Like while Rust will be able to push more and more into bigger applications, and Rust's appeal is going to be either extremely high performance or low footprint. Like that is the sweet spot, because there is conceptual overhead and just friction using Rust compared to other languages. Some people, I know this, without opening a ginormous can of worms, I think there are other languages that are easier to onboard, like to get comfortable with and to get productive with, and at the cost of higher overhead. And I think there are a lot of cases where those languages, Rust will get more adoption, but will probably not become ginormously important in those spheres. I think that Rust really shines is low footprint and like close to the metal. Right?
And are there ways to avoid zeroing out buffers? Like
I don't think so. There's
some kind of pooling or something like that.
Pooling is not at all. Yeah, you don't want to pool in a level. Like you're fighting the allocator, you can't reclaim memory. You gotta deal with pooling. It is not recommended to do. And would not be an option like in Linkerd, etc. So
is the primary drawback that you can't reclaim memory? So you sort of have an
Can't,
ever-growing,
you can't, I mean, you
or
can't
not so
reclaim
easily.
memory, not so easily. You're not, there's the argument, so you can't use the stack. Like, you oftentimes, all you want to do is like throw a stack buffer, right? And all that, even, and I'm not even talking about like the asynchronous stack. I'm just saying you're calling pull read, you just allocate like a stack, an uninitialized stack buffer, and that is just like the cost of doing that is just incrementing a pointer. It's not going to page memory into it, because like you're not touching the memory. That's the entire point of not zeroing it out, right? It's like you allocate a like 4K stack buffer, or I mean that's going to be a page size anyway. But like if you had a past page boundary and you allocate a 4K stack buffer, that's basically free if you don't zero it out. Right now, I mean, again, we are talking about cases where you're close, like low overhead cases where that's measurable, but that's, I think, the case, like that is the spot that Rust is going to shine in. Databases, proxies, just general infrastructure in that level, right? Or even not even, and again, people keep talking about like high, like talk about fast and latency and all that, but there's also low footprint is a very important case. Like, write a very light service that is unmeasurable running in the background, right? That's another spot. You don't want to be cycling. You don't want to be cycling in memory, when you want to be able to free up memory back to the operating system. In those cases, you can't run a buffer pool in that case, right? I mean, you could, but that is not it. So,
Right.
So for me, my opinion here is we have an opportunity to make this work, right? Make this work as well as possible. Then there's another case that so while I think the argument of make it match async read and async write is appealing, there is the fact that this, like, async read and async write are actually async read and async write are going to be more low level and used far less than read write, because the end user doesn't call pull read and pull write directly. They call the async functions read and read exact and etc. And those can match, like those in those functions you can have like read just passing a slice that requires zeroing it out, because then you can have like what I'm calling read buff, because that's what Tokio just has right now, which takes in a T buff, right? So you can have multiple entry points and hide that detail, the fact that you're changing the core of the trait. And that means it gets limited to those who implement async read and async write directly, which at that point, you're also throwing in pin to the mix and the context object. So you've already significantly deviated, and you've already added non-trivial amounts of added complexity to the implementation. So the argument of it just matches standard IO read and standard IO write doesn't really resonate with me, because it doesn't match on fundamental levels because of pin and the context and the returning pull instead. Like, it's just a completely different trait.
Yeah, it's certainly not. Okay, I see your point. It's definitely not. It's not an exact match, whatever you do. So the question is a little extra deviation. But now then there comes the question, well, if you're not going to use a slice, then what should we use? And I don't know how much we want to go into it in this call right now. I know there are a couple of options, and that's sort of the debate. One other thing I'm wondering about is, I guess the other question that I'm worried a bit about the fact that if Tokio adopts one definition, and if we adopt instead, let's say, the definition that's in futures IO, then the question is, how does the bridging work and what kind of costs are implied there? And I guess I worry if it means it would be nice if we didn't like double zero all the memory, for example, just to be conservative.
It would be nice. Yeah.
I'm not sure if that would be required or not. I guess it might depend on the solution.
I mean, I would say that it depends. Like if you, the cases I'm bringing up I'm not bringing up out of like, I don't know. They're real cases that I think if you want to standardize something like something that is going to be used across the ecosystem, it has to satisfy the use cases of that ecosystem.
Mm-hmm.
Like if you like Tokyo is not going to deviate lightly, right?
Mm-hmm.
It's not like it's not a whim, right? Obviously,
right.
Like,
so you're saying we run a risk
because there's nothing. Yeah, and it's basically like and then there's the vectored case, which like the fact is right now using the strategy that standard provides for vectored operations is just not usable. Like we can't Hyper can't take advantage of it. It's like I can't it's just there's flaws in it.
This is the futures IO trade.
No, I'm just talking about even like the IO read and IO write. I think those were stabilized way too early. I mean, I didn't really pay much attention. Yeah, just like IO slice, like the read vectored and write vectored and those, like it can be fixed, I think. But I think I described this in a comment on the PR to Tokyo. It's simply that the caller needs to know if the handle supports vectored operations. Like it's not a transparent thing because the caller has to behave differently based on if we're going through vector or not.
Right. So
there's.
I remember this comment. So the idea was I'm going to give you a series of buffers, and the default implementation can basically ignore all but the first buffer. But you're saying that the caller, like if they do something like they have a really small first buffer and a really big second one, then it's going to be super inefficient.
Yep. I mean, yes, basically. I mean, there's ways of mitigating it, but it's just not. I'm not gonna say it's completely 100% broken. It's just not ideal.
There's no. I mean, the obvious way to support that would be to, offer a method that asks you.
Yep. I believe that is one of the proposals. So, which means it's fixable. You can add that method to standard IO read and writes and have a default implementation.
And we were talking about this, and then I was trying to ask you, and I think you said that, like, the question would be essentially how far up does this rewrite extend? Like somewhere at the top, somebody's allocating these base vectored buffers, and they are going to have kind of two paths in this, right, the way you're describing it. And that doesn't sound great. Maybe it's what's necessary for performance. I guess the more that it's encapsulated within some library that I never have to look at, the less I care.
Yeah,
short.
I mean, that's part of the idea of bytes as well, in that bytes is just the general idea of storing buffers, and then you just take this entire buffer and you say write this, and it does the right thing.
And in the trade object version of this API, let's back up because people may not even have followed. But okay, I think we covered async read, async write pretty well. But so we have stream, we have async read, we have async write. I just want to scroll down this list and see what you think about any of these other things. I mean, it seems like. What about things like async destructors, for example, or async closures? Are they things that you feel the need for? Or?
Async destructors, 100%. I think that would be a very valuable thing to add. And the sooner the better. Like it's basically right now, there's no way to take advantage of the cleanup on drop that you can do in sync because there's no async destructor. So yes.
Have you seen Boats' proposal on this?
Yeah, I saw. I mean, okay. So I saw the initial tweet and blog post, and I mean, I responded quickly. I've not spent a lot of time internalizing the various trade-offs of the details. Um,
I was just curious if you had
it,
a reaction of like, I can immediately say that I won't solve the use case I'm looking for, or if it does seem like it
I
would work.
mean,
I think the core challenge
both.
would be like, you have to have a drop, if I recall, I'm trying to remember now. Basically, you had a pull drop method, right? But
yeah.
and you still had to be able to be dropped.
Yeah. So I think the proposal there was you had a completely separate. You had the normal drop, and then you add an async drop variant or a pull drop. I don't remember if it's pull drop.
It was pull drop.
It was pull drop. Yeah. And then the cogen generated both, and like in async context, it would call the pull drop. My initial reaction was that it seems difficult to write that by hand, to write a pull drop by hand, because if it's called multiple times and you're responsible for freeing the memory internally, there's like you have to keep track of which is freed. It just seemed a bit tricky and then I proposed an alternative strategy, which was instead of pull drop, you have pull drop ready or something like that, which is a function that just gets the value ready to do a synchronous drop. So instead of just calling one or the other, you for in an async context, you just pull drop until it turns ready, and then you call normal drop. So in that case, usually that covers the pattern in that, like async flush, all you want to do is the pull drop ready, which is finish the flush, make sure all the data in your async write is written to the socket, and then it's a ready, and then you call a regular drop. Or like it's just generally you can do the async work first and then say you're ready and then do the actual memory dropping freeing stuff separately.
That seems like a minor variant. I mean, it seems good from first blush.
Yeah, I don't know.
But again, not like a major, but the basic model seems intact.
So I think the basic model of adding another function to the drop trait is it sounds like the best strategy. I've not put a lot of thought in it. I've not put a lot of thought into considering all the details. I expect there will be vast amounts of energy and put into figuring out, like discussing all the alternatives, bike shedding every single possible variant, another 400 comment thread that I'm not going to jump into. I'm just like, you know what? It sounds great. I will use whatever you have. I expect it to work fine and be amazing. I'm not going to dig into that. I'm not going to jump into that RFC.
So the only, I guess the main other things on this list, well, there are things like communators, or not communators, but utilities, so to speak, like join and select and so forth. I imagine Tokio may also offer its own variations on these. Not sure.
Right now it doesn't, because it just says you can pull in futures and it works because it's uses standard feature as the common interface. I expect that Tokio will need to provide its own that may or may not just be a copy, just to have something out of the box without pulling in the dependency and dealing with. Again, I might just re-export it now, but that's not entirely a long-term strategy. So I don't know what I'm going to do yet.
All right. Well,
I don't know. I think my recollection of the futures crate is that it's, it just seems like it's got a lot of utilities and lots of things in it, when all I would probably want to re-export is a few. There's some feature flags. I haven't looked into if the feature flags support the permutation I care about. Part of it is like Tokio 0.1 got a ton of flack for being a heavyweight dependency. Tokio 0.2 trimmed that down a lot, and we'll keep trimming it down. Seems good to have lightweight dependencies, but that means I need to care about like what I depend on. Right?
Sure.
So,
yeah. And I guess I think
select right now depends on proc, like the proc macro hack. So it would be really great to stabilize the ability to avoid proc macro hack, because that is, being able to do that is really amazing. Like the functionality that you get from proc macro hack is amazing, but there are limitations that are pretty annoying, and it would be great to just get that stabilized. Like,
yeah, that's kind of a.
is there a yeah.
That's kind of a good orthogonal. I was going to ask whether there are like other features that are sort of not directly related to async, but that would really help.
Yeah. Proc macro is an amazingly powerful piece of functionality that would be nice to get. Just keep pushing on. Like, it's already really really good. I mean, the problem is proc hack kind of gives us that extra taste and flavor, and like,
sure,
please stabilize it. I mean, I know there's lots of issues with stabilizing it that you can just hide by having proc macro hack. Like, proc macro hack doesn't have to worry about the same stabilization issues. So,
yes.
Is there maybe there might be like a few like temporary things that you can do to remove the limitations that proc macro hack has?
Yeah, I don't have that in cache. I'm not sure.
Yeah, I don't remember what they are, but like, if there was more like stepping stones there. I think the biggest issue with proc macro hack is you can't nest them, and that's a big problem for select right now. So you can't nest. Okay, that's not true. It does another hack to work around nesting selects that has other issues. I feel like I don't remember. It may just work perfectly because David, I don't know why he does it, but it definitely seems like a hack.
All right. I think we'll all have to investigate that, but I actually have to run for another thing anyway, so we should probably call it here, but it seems like we reached a good stopping point.
Good.
And I'm happy to hear you think Stream is pretty good. I guess, well, maybe I'll follow up with you later about, I'd like to figure out about the service trait, but I don't want to do it now. So thank you for taking time to talk.
Yeah,
see you later.
Thanks. See you later.
See ya.
How do I exit?